Hello student, hi, good evening. So today we are going to discuss about PN junction diode. Okay, so in PN junction diode we are going to see what today depletion region. Okay, how depletion region form. So we will see about depletion region. Okay, how depletion region form across the junction. Which junction? P and N junction. Okay, how depletion region form across P and junction. Okay, so today topic is about depletion region. Depletion, depletion region formation, depletion region formation across the junction, across across the junction. Okay, so today we will see about this. Okay, how actually this depletion region form, why it form across the junction. Okay, so now see across the junction. As you know very well that PN junction. How PN junction form? PN junction form what by taking one P type. P type. Okay. So we are taking one P type semiconductor, one P type semiconductor, and one N type semiconductor, and one N type, one N type semiconductor. Okay. So one P type semiconductor, one N type semiconductor. Okay, so both are the part of what? Both are the part of silicon. Okay, silicon crystal. Both are the part of silicon crystal. Then what we do? We just bring them in closer contact. Yes, we just bring them in closer contact. So like this P type. We will bring P type in closer contact with N type. Yes, P type with closer contact with N-type. In this way, we are forming what? P-N junction, which both are what? Both are the part of single crystal. Okay, both are the part of single crystal. Or in practice, in actual practice, how we are forming this P-N junction like this. We will take first what? We will take first single silicon crystal. We will take first single crystal silicon. Then after that, by partition, by making partition, we will what? We will make PN junction. How? By different doping. One side of this region, we will dope this region. We will dope this region with trivalent impurity, and we will dope this region with pentavalent impurity. Okay. So by doping this region with trivalent impurity, like aluminum, gallium arsenide. Okay, so like this, if we will do with this pentavalent impurity, then there is a p-type. Yes, p-type semiconductor. So it is a region of p-type semiconductor by trivalent impurity. Okay, so by doping trivalent impurity, because this trivalent impurity has only 3 electron in its outermost shell, and here the silicon has what? 4 valence electron. 4 plus 3, 7. 7 means there is a deficiency of one electron. Deficiency of one electron, which is represented by excess hole. This is my hole. This is my deficiency of electron, means this is my hole, which is positively charged empty space. Positive charge empty space. This positive charge means it is p-type semiconductor. Similarly here we are doping this region with pentavalent impurity. Pentavalent impurity like phosphorus. Phosphorus has how many electron in its outermost shell? 5 electron. Okay, here silicon has 4 electron. 4 plus 5 is what? 9. 9 means what? One excess electron. This excess electron has negative charge. Okay, this excess electron has negative charge. Negative charge means n-type. Negative charge means n-type. So therefore it is n-type semiconductor. It is p-type semiconductor, which we have formed. Okay, which we have formed in the same silicon crystal in two regions, two different. Yes, in two regions. So by making the partition from this single crystal, one of the reason we are doping with one of the reason we are doping with trivalent impurity, other reason we are doping it with pentavalent impurity. Okay, so in this way In this way, we have found what PN junction. PN junction. Okay. So now PN junction. So this is what actual procedure. Actual procedure to form what, to form the PN junction. Okay. To form PN junction. So then after that to make the PN junction diode, what we do? This is my P. This is my P region and this is my N region and N region, and we will connect this P region and N region through wire. Through wire. Okay. Both P region and N region is connected through wire through the metal contact. Through the metal contact. These are my metal contact. Yes, and we are making the contact to N region and P region through the wire. Okay, through metal contact. Now this is my PN junction diode. Now we can say that this is my PN junction diode. Okay, PN junction diode. So this is single. This is only single silicon crystal. Okay, single silicon crystal. We are on single silicon crystal. We are making the partition on the single silicon crystal, and partition of two different region, and one region is doped with trivalent impurity and which will make p-type semiconductor, and other region is doped with pentavalent impurity which will make n-type semiconductor. Okay, so both are joined together. Okay, so this is what is junction. This is junction. So this is PN junction. PN junction, and making the contact of this P region through metal. Okay, so we are connecting the wire. Okay, we are connecting the wire to the P region through metal contact. Similarly here we are connecting the wire to the N region through metal contact. So it is a PN junction diode. Yes. Now we will see how this depletion region forms across the junction. So for that we have to go for what, open circuit diode. Open circuit. Okay, so operation of open circuit diode. Okay, operation on open circuit diode. See here. Operation. We will see here operation. We will see operation of PN junction under open circuit condition. Operation of PN junction. PN junction. Operation of PN junction. Okay, operation of PN junction. PN junction under open circuit. Under open circuit. Open circuit. Under open circuit condition. Okay, open circuit condition. We will see what operation. See here. This is my PN junction. Yes. So this is my P region. This is my P region, and this is my N region. N region. Okay. So this is my metal contact. Through this is my wire, which is open-ended. Both wire are open-ended. Nothing is connected through this wire. Okay, so this is my P region. This is my N region. Okay, N region. If we see here at P side, there is a lot of hole. These hole are what? Majority charge carrier. These hole are majority charge carrier. Okay, majority charge carrier. Hole. And here is a lot of electron. So these electron are majority charge carrier electron on N side. Okay, these are majority charge carrier electron on N side, and hole on P side. These are hole on P side. So, and here minority charge carrier are electron on P side, and here minority charge carrier on N side is hole. Hole are minority charge carrier. On N side. Okay. So now these all hole on P side is what? Hole on P side is positively charged empty state. Positively charged empty state, and every empty state is what? Every empty state is neutralized by every empty state. If you see, every empty state is neutralized by equal amount of positively charged. Equal amount of positively charged positive charge. bound positive charge that is associated with atom. If you see at p side there is a p side means there is what acceptor atom. At p side, if you see p side has what p side has this empty state. Okay, p region has empty state. Empty state means it is positively charged empty state. Empty state. This is positively charged empty state. Okay, in p region. In p region, which is what? Which is neutralized. Which is neutralized by what? Which is neutralized by equal amount of positive charge. Which is neutralized by equal amount of negative charge. Sorry, this is what? This is neutralized by equal amount of negative charge. Okay, this empty state is what? Neutralized by equal amount of negative charge associated with this acceptor atom. Acceptor atom. This is my acceptor atom. Acceptor. This is my acceptor atom. Acceptor atom. Acceptor atom at p region side. At p region side. And here n region side there is what? There is donor atom. Donor atom. Okay. Donor atom has negative charge. Yes, negative charge. Donor atom has negative charge. Yes, negative electron. Donor atom has electron and acceptor atom has hole. Acceptor atom has hole. Hole. And this hole is what? Hole is neutralized. Hole is neutralized by equal amount of negative charge associated with this donor atom. Associated with this donor atom. This is my donor atom. Yes, negative charge. Donor atom. This is my hole. Hole. P side there is a hole, and this hole has what? Positive charge, which is what? Which is neutralized by what? Equal amount of negative charge associated with acceptor atom. Similarly, here in n side, if you see n side, in n side there is what? There is electron. Yes, there is what? Electron charge. Okay, n type has what? Electron charge, and this electron charge is what? Is neutralized by equal amount of positively charged, equal amount of positive charge associated with donor atom associated with donor atom. See, this term somewhat this term is, to understand this term, this is somewhat complicated. So I means what? I means actually this is my p region. Okay, so everywhere you will not get this information. Okay, so information, because this negative charge is there. Okay, so because of some complexity, so I'm not showing this negative charge here. Okay, every hole has this negative charge. Okay, associated with acceptor atom, so that they will become neutralized. Okay, so for that purpose I am representing this here. Okay, so we have to understand properly, because p side there is a lot of hole. Okay, so lot of hole, and every hole has what? Positive charge. This every hole has what? Which type of charge? Positive charge. What charge is there with every hole? Positive charge. Okay, so every hole is nothing but it is a positively charged empty state. Positively charged empty state. So every hole will get neutralized by equal amount of what? Equal amount of negative, equal amount of bound negative charge associated with acceptor atom. Okay, so this I'm just concentrating only in this portion. Okay, so in this area, because it is somewhat difficult to understand. Why I am saying again and again, because these whole I am not representing this acceptor ion here, because it will get complicated to represent to teach you on the same place, because so that's why I am making it separately. Okay, so these are what? Hole means what? Positively charged empty state, and every hole is neutralized by equal amount of bound negative charge associated with acceptor atom. Similarly, on n side there is a majority charge carrier, electron. There is a majority charge of electron. This electron has negative charge. Every electron has negative charge. Every electron is neutralized by equal amount of unequal amount of bound positive charge, equal amount of bound positive charge associated with donor atom, associated with donor atom. Okay, so this is what I want to make you understand. This is the main point where I want to make you understand again and again. Okay, so this is main important part. If you will get, if you are able to understand this, okay, so everything is easy, everything is easy. So because it is more important to understand depletion region, how depletion region form. Yes, so now we will see how actually the depletion region form. See, under open circuit condition, nothing is applied, no biasing, nothing. Okay. So initially, what happens? Now what happens in this diagram? See, there is a hole. There is a lot of hole. Yes, there is a lot of hole at P side. At P side, this is P side. This is N side. This is N side. There is a lot of hole at P region. At P region, there is a lot of hole. Hole. How many hole? So see, this many hole is there. Okay, so at n region, if you see coming to n region, these hole are decreasing. Okay, decreasing slowly, these hole are decreasing. There is a hole in majority, hole in majority. If you see this process, this process, higher concentration, lower concentration, higher, lower. In open circuit condition, what happens? In open circuit condition, there is always what, if you see in under open circuit condition, the operation is like, operation happen like this. Operation happen like this. There is a process. There is some type of processing is happening. Some type of processing is happening. Okay, so within this P and N region, what is this process? Is nothing but a diffusion, by the name of diffusion process. Okay, so this diffusion process happen when this diffusion process happen. This diffusion process happen only when there is a difference in the concentration. Difference in concentration. If there is a difference in concentration, if you see concentration in this region is very high, concentration in this region is very low, or not. If you see concentration very high, concentration very low, so means there is a difference in concentration. Difference in concentration. Wherever there is a difference in the concentration, then there is a migration of the charge carrier. Migration of charge carrier from one region to other region. One region to other region. So therefore, these charge carrier will flow from higher concentration to lower concentration. Higher concentration to lower concentration. These charge carrier will start diffusing from higher concentration to lower concentration. Okay, until and unless these charge carrier, until and unless this concentration will become what, will become constant. If this concentration will become constant like this, if you will see, this here, what is concentration? Zero, because everything is in equal manner. Yes, concentration here is constant, but here is not constant. Okay, so concentration here is not constant, means there is difference in the concentration. Concentration here is constant, means here diffusion is zero, but here diffusion is high. Okay, diffusion means migration of charge carrier from higher concentration to lower concentration, higher concentration to lower concentration, until and unless this concentration become constant. Okay, and diffusion will then diffusion will stop further. Diffusion will stop when this concentration become constant. Constant means this difference in concentration become constant, means diffusion will stop automatically. Similarly for electron, here in electron, here majority charge carrier electron on n side. If you see n side electron is higher. Electron concentration is higher. Then this electron concentration is slowly decreasing toward what? Toward P region. Okay, toward P region. This concentration is slowly decreasing. Here concentration is high. Electron concentration high concentration, low concentration on P side. Now like this P type of this on hole, majority charge carrier hole will start migrating from P region to N region. Similarly, electron will start flowing or migrating from N region through junction to the P region. Similarly, here hole will start flowing. Hole will start migrating from P region through the junction into N region. Similarly, electron will start migrating from N region to N region through junction into P region, okay. So now they will start flowing from one region to other region. So this time, in this way, diffusion will start. Now we will see, once this diffusion will start, then what happen. Once this diffusion will start, here you see, here this is diffusion will start like this, okay. So here is my junction, and this is my another region, and this is my P region, okay. So here is my metal contact, and this is my lead, which is open circuited, okay. So metal contact, and this is my open circuited. Now, as the electron, if you see here, let us see, this is my region. So for understanding purpose, I am just denoting it. See, these are my negative charge, these are my what, bound negative charge associated with acceptor atom, bound negative charge associated with acceptor atom. For understanding purpose, better understanding purpose, that's why I am just making this, okay. So this is my positive charge, here positive, here positive, here positive. These are what, these are bound positive charge associated with what, associated with donor atom, this, okay. So if you see here, hole, everywhere hole is there, hole has positive charge, which is what, neutralized, by, hole has positive charge, which is neutralized by what, equal amount of negative charge associated with what, acceptor atom, okay. So and here minority charge carrier are hole, electron are minority charge carrier, okay, electron. Here electron, everywhere electron, okay. So with every positively charged, with every bound positive charge, there is a electron, okay. So what is the meaning of this? Understand again and again and again. This is my positive charge, this is my what, hole is nothing but positively charged empty state. Hole is nothing but positively charged empty state, which is bound by what, equal amount of negative charge associated with acceptor atom. Similarly here, electron is what, negative charge, negative charge electron is neutralized by equal amount of positive charge associated with donor atom, okay. So that's it. Now here hole is in majority charge carrier, okay. So hole is majority in P region, here electron is majority in N region. Now what, now diffusion will start from P region to N region, see. Now these hole will start migrating from P region to N region through this junction, okay, this junction is not still here, okay. So it is like this, so it is not there, still it is not there, okay. Once the hole, so everywhere hole is there, just positively charged empty state is there, means hole is there, electron is there, electron is there, okay. Just this is just what, partition between this P and N region. Nothing is there, still nothing is there, no depletion region is there, okay. So now this hole will start migrating from P region into N region through this junction, similarly this majority charge carrier electron will start migrating from N region to P region through this junction, now see, as the number of hole will start migrating from P region to N region, then here some of the hole will get recombined with what, with majority charge carrier electron, will get recombined with majority charge carrier electron. Okay, so these are what hole, these are hole. Okay, some of these are hole. See, now this hole has this, some of the hole. Let's see, just a minute. See, some of the hole, some of the hole has been some of the hole has been jumped from P region to N region, or some of the hole has been migrated from P region to N region, and they will quickly recombine. They will quickly recombine with what? Majority charge carrier electron. Majority charge carrier electron. Okay, they will quickly recombine with majority charge carrier electron, and after that immediately will get disappear. Immediately will get disappear from the scene. Immediately will get disappear from the scene. Okay, so now I have shown you what I have shown you. First, this hole came here. Okay, from P region to N region, some of the majority charge carrier. I am not representing here which hole, because there is a lot of holes. Okay, so in millions, in count of millions of electron is there. Okay, so they have migrated through this junction into an region. Okay, and they have recombined with what? Majority charge carrier electron, and immediately what? They will get disappear. They will get disappear from the scene. They will get disappear from the scene, and therefore these positive charge, therefore these positive charge bound accept an atom. Okay, so now these positive charge, on n side will no longer have any electron, and they are okay, so they don't have any electron, so that they can neutralize. Okay, so they are no longer neutralized. Okay, so they are not getting any chance to neutralize, because the electron that has disappeared because of recombination of the hole. Okay, so this, now this electron, some of the hole quickly recombine with majority charge carrier, and will get disappear from the scene, and this recombination also result in the disappearance of some of the majority charge carrier electron. Okay, so here some of the majority charge carrier electron will get also disappear from the scene. Okay, so they will get disappear. So therefore the positive charge on n side. Okay, so positive charge on n side is depleted. Okay, so these are immobile. Now these positive charge are immobile on n side. Okay, on n side they don't have any free electron. So that for neutralization, so therefore neutralization, they are unneutral. They are what? Uncovered charge. They are uncovered charge, or they are immobile charge. Okay, so immobile ion that we can see. So therefore we can say that in n region, and there is a region on n, in n in n region, there is a place, there is a portion near the junction which is uncovered. Okay, so these are uncovered region on n side. Okay, so therefore in n side there is some region closer to the junction which is uncovered. Similarly when this electron will start migrating from n region to p region, then some of the majority electron will quickly recombine recombine with this hole. Okay, so some of the majority electron will quickly recombine with this hole when this electron will start migrating from n side to p side. Okay, n region to p region. Some of the electron will quickly recombine with hole, and will get disappear from the scene, similar like hole. Okay, similar like hole case, and will get disappear from the scene. And after that there is after that some of the negative charge on p region are depleted of are depleted of whole. Some of the negative charge on p side is depleted of electron, means they don't have any more holes, so that they can neutralize. Now they can't neutralize, means they are unneutral. They are immobile ion, and they are uncovered ion, and hence we can say that on p side there is a some region near to the junction which are there is a some region near to the junction which is depleted of what? Which is depleted of hole. Okay, which is depleted of hole. And similarly on n side there is a some region which is depleted of electron, Okay, why it is happening? Because some of the charge carrier is coming very quickly and recombined with majority charge carrier, and will get disappear from the scene, disappear from the scene, and they are no longer present within this pn junction. Okay, so within this pn junction layer. Okay, so therefore because of that the sum of the charge on p region and n region are n region, they don't have any electron, like positive charge on n region, they don't have any electron, so that they can neutralize. Similarly there is a sum of the negative charge on p region which don't have any hole, so that they can neutralize. And hence we can say that on p side and n side there is a some region which is uncovered, or which is depleted of electron as well as hole. And these depleted, so therefore these uncovered region, yes, these uncovered region near the junction will form depletion region. Will form what? Depletion region. Okay, so therefore in this way the depletion region form across the junction. Once there is a depletion region, there is a establishment of what? Electric field. Why? Because wherever positive and negative charge is there, wherever positive and negative charge is there, electric field is there. Force of attraction is there. Electric field is there. Once electric field is there, potential is there, and that potential is nothing but built-in potential. Yes, that potential is nothing but built-in potential. Yes, this built-in potential is the threshold that we have to cross in order to make this device conduct. Okay, make this device to conduct. So therefore in this way depletion region form. How depletion region form? As we know very well, when the diffusion will start. Diffusion means migration of the charge carrier from higher concentration to lower concentration. For time being, let us say the whole is migrating from p region to n region through this junction. Then some of the whole will quickly recombine with some of the majority charge carrier near to the junction, and will get disappear from the scene. Because of that, there is a sum of the positive charge on n side which do not have any electron, so that they can neutralize. And hence we can say that on n region, on n side there is a some region near the junction which is uncovered, or which is depleted of electron. Okay, so similarly in case of electron, when this majority charge carrier electron will get migrated from n region to p region, they will get quickly recombined with hole, some of the majority hole, and will get disappear from the scene. And this recombination will also result in the disappearance of some of the majority hole. Okay, so in this way we can say that now on p side there is a sum of the negative charge which do not have any more hole, so that they can neutralize. And hence, and we can say that on p side there is a some region near to the junction which is uncovered, or which is depleted of hole. So in this way these uncovered region near the junction form the depletion region. Okay, form the depletion region. So this depletion region has positive charge and negative charge. As we know very well, wherever there is a positive and negative charge, there is a establishment of electric field from positive to negative direction. From positive to negative, there is a establishment of electric field. Electric field. Once the electric field is there across this length, then there is a appearance of what built-in potential. Built-in potential. So built-in potential will get appear across this junction. Across this junction. This is the threshold voltage. This is the threshold voltage that we have to cross. That we have to cross in order to make this device conduct. In order to make this device conduct. If we want to make this device conduct, if we want to make this PN junction diode conduct, then we have to what? Then we have to cross the threshold. That threshold voltage is nothing but built-in potential. Built-in potential, which can be possible only by biasing, suitable biasing. Okay, so biasing means by providing the appropriate supply to this device in order to cross this junction, so that this device is able to conduct. Device is able to conduct. Okay, so this is only about depletion region. Okay, so we have seen how depletion region form. Okay, how depletion region form. This is the way of formation of PN junction, and this is the way of formation of depletion region. Once the depletion region form, this electric field is there. This electric field will oppose. This electric field will oppose the further migration of charge carrier through the junction, and but it will support the flow of minority charge carrier. Okay, this electric field will oppose the flow of majority charge carrier, but it will support the flow of minority charge carrier. And this built-in potential is what? Built-in potential will limit the flow of diffusion process. Okay, so it will limit the diffusion process across the junction. Okay, so this built-in potential will what this built-in potential will limit the diffusion process across the junction. Okay, ultimately we can see that it will limit the diffusion current through this junction. Okay, so that's all about PN junction. Okay, that's all about PN junction diode and depletion region formation under PN junction diode. Okay, so thank you very much. Okay.